everybody. This is second time lucky for me. This is the second time to do this video because the first time I forgot to put the headphones on again. I thought I was feeling rather free and comfortable, and then thought, oh no, I haven't got the headphones on with the microphone. Never mind. So today, quite a short one I think, because we'll talk about equivalent fractions. That ties in with your work for today. We'll have a quick word about the water cycle. And then I don't need to talk about L1 on this video because L1 English children will be meeting at 1 o'clock. So there we go. So let's get cracking. Equivalent fractions is your theme for your work today. If you were with us at the meeting on Wednesday, we had shared some pages and talked a little bit about equivalent fractions, so it shouldn't sound new. And we mentioned that equivalent, even though it's a tricky word, it sounds like equal, doesn't it? Okay, so equivalent fractions are when we see that we've got different ways of expressing, saying, of writing the same fraction, but using different numbers. Okay, so we used the example of 4/8, for example. Okay, 4 out of 8, 4/8 is exactly the same as 1/2. Yeah, okay, so the words sound totally different, and even when we're looking at it, we've got a numerator of 4 here and a numerator of 1 here, a denominator of 8 here, a denominator of 2 here. So they look very different, but we know that they are worth exactly the same. If you've got a whole pizza split down the middle, 1/2, you would think that's exactly the same, wouldn't you? Of the same size pizza, but if that same size pizza had been cut into 8 equal parts, and you had 4 of those 8 equal parts, you know that's the same as having half of the pizza. And in our meeting, we had a little look at that diagram whereby 4/8, 4 out of those 8 parts there, are just the same as having what is cut into what looks like a half. Okay, so we know they're written differently, we say them differently, but they're worth the same amount. That's an equivalent fraction. Okay, again, we could make a whole long list, couldn't we? We could say, what else is equal to 1/2? Somebody give me an idea. Can you, somebody saying 2/4? You know, I can't really hear it, but I just like pretending. I can hear somebody saying 50 hundredths. Oh yes. Yep, you can still see. And we could go on forever and ever. Pardon somebody? Pardon somebody so tricky? Really? That hard? 31 60 seconds? Oh yes, you are absolutely right. And we talked about being able to spot equivalent fractions of 1/2 in that if your numerator is half of your denominator, 1 is half of 2, 2 is half of 4, 31 is half of 62, 50 is half of 100. If you have that pattern, your numerator is half of your denominator, it will be an equivalent fraction of 1/2. Okay, and obviously not all fractions, that's not true. Many fractions have equivalents. We could take 1/3, and from your work that you've done in your Intermath book, some of you might already be saying that an equivalent fraction of 1/3 is 2 out of 6. Okay, so there are others that link up together. Okay, 2 out of 6, 2, 6. There are some fractions that just don't have an equivalent. Okay, for example, no, actually, you know what? I'm not going to go there today in case we get ourselves in a pickle. Okay, in case I get myself in a pickle, more to the point. So, equivalent fractions. We've got some good examples, and I have been looking forward to today because when I found this bar of chocolate, I thought, I can use that to maybe illustrate some equivalent fractions. So I haven't opened it until now. I don't quite know how this bar is going to work in terms of how big or how many of the little squares or rectangles there are going to be in it. I feel like Charlie Bucket opening, no golden ticket, just a golden wrapper. Okay, so I have got 1 bar of nutty chocolate here. It's got lots and lots of pieces on it. Okay, so let's put that down. I can't eat it yet until we finish. I realise I just need to move the paper. Just a second. Amongst yourselves. Move that up a little bit. Actually, I can move it down. Down and use that top piece that I haven't used. Okay. Right, so at the moment we have 1 whole bar of chocolate. Yeah, 1 whole one. And I will need to break it here to break it into, I hope I can do it without, oh no, that's not worked very well. I'll tell you why it's not worked very well, because instead of me cracking it right down the middle, look what's happened. These are not halves, are they? Why are they not halves? Exactly, because this is not equal to this. So that plan didn't work, did it? That plan didn't work. I shall just have to abandon that plan and eat the chocolate. What I was hoping to show you very quickly was obviously I was thinking, oh, I could break that up, then I'll take half of it. Maybe I could try that. I'll take half of it. Let's see if I can. Okay, right, apart from the little nut. That is now half. Those little nuts sticking out. I'll eat those later. Okay, that is half of it. Okay, so if I take that half, if I break, oh, I wonder if it's going to do it without, I think the nuts are making it a half. Oh, there we go. Okay. Oh, nuts on the floor. So what have I got here? Out of the whole bar, with that broken bit down the bottom. Okay, ooh, can you see? Out of the whole bar, here I've got half, but I've also got 2/4. Yeah, up the top end here. 2/4, the same as a half. I could, oh yeah, it's working now. Just ignore that bottom half and focus on the top half. Okay, oh, that's working better. Okay, so I've still got my bottom half down here, which I've squished up together with the, and here in my top half, I've got 2/4, and I've also got 4 what? Because I've got 4 here, but also that bottom half would also make another 4 chunks that size. So here I've got 4 out of 8. Okay, it doesn't look like 8, but if I were to make all of these, I'll try, even though I might have to jigsaw some of these together. Oh no, it's all breaking. That bottom half is just too crumbly. Okay, so whether you're understanding, I don't know, I hope so, but it's a really good excuse for me to eat this chocolate afterwards, isn't it? Okay, so I've got 4/8 at the top and the other 4/8 down the bottom. It's just that I haven't broken them up yet. If I split these again, oh, you're being very patient. Oh, this is so tempting me to eat it. See, if we were all together, we could have broken all this up and then eaten it at the end of the lesson, couldn't we? Okay, so now we're going to slide off in a minute. I've still got the bottom half all kind of crumbled up, but the top half, okay, the top half, you can probably just about see, I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, I could have done the same with the bottom half to have 9, 10, 11, 12, 13, 14, 15, 16, and I would have had 16 parts that are all this big. Okay, I've still got my same 1 whole bar of chocolate, but when the chunks are this big, they're in 16ths. Okay, so that is 1/16 of the whole bar of chocolate. If I were to break all of those into the individual squares, I'll just do it with the top half. You ahead? You see if you can think how many little squares there are in this whole bar. So there were 16 parts with 2 squares in. Okay, now in this top half now, this is the top half of my bar of chocolate. The top half is all broken into individual squares. Gosh, it's so tempting. There are 16 of them. So there are 16 at the top. And if I were to break up that bottom half, there would be 16 little squares at the bottom. So 16 in the bottom half, 16 in the top half. How many little squares? 32. Okay, 32. So each little square, okay, I can't go any smaller with these. Each little square is 1/32, we could call that. Can't call it 1/32. 1/32 of the whole bar. Okay. So altogether, if I count all of those individual little squares, to get to the whole bar, obviously there would be 32. In fact, I shouldn't put an equal sign there at all. That's not equals at all. I'm now saying I've got 32 30-seconds. My denominator and my numerator are now the same. I've got one whole bar. Okay? For my half bar, I've got 16. Where am I? Of those 30 seconds. Okay? When they were that size, do you remember? I had, and there were 16 that were that size, I had 8 of them. Okay, and so forth. So we can see here as well this link between individual fractions. I hope that's helped more than just giving me an excuse to eat some chocolate. I did have a vested interest in that. Let me just pour them now. There, all in the bowl. Wait it on my own, or do I share it? I'll have to tell you next time what I decided to do. Right, okay, so equivalent fractions, hopefully that's given you a little bit more to think about with that, and you've got some work to do, colouring and filling in down here. Okay, there is a new symbol for some of you on question 3. It looks like this. It's an equal sign with a bar through it. So if it's an equal sign, we know it means equals. If it's an equal sign with a bar through it, means not equal to. Okay, so let's see. On one of them, the first one of those, you've got a quarter. Can you see? Yeah, you've got a quarter and you've got a half. Okay, so a quarter, is it equal to a half? Okay, so you've got to think of the same sized whole one. Is a quarter of that whole one the same size as half of the same whole one? No, a quarter is much smaller, isn't it? So on that one, we'll say it's not equal. Boom. Okay, those two are not equal. So between the fractions in that question, there is a square for you to either enter the symbol, yeah, that's an equivalent pair of fractions, or no, they're not equal to each other. Okay, and with question 2, if you refer back to the colouring that you've done here, you'll be able to see quite visually what the equivalent fractions are. Okay, right, now for the second part of your work today, I've sent you a link to a YouTube clip which I found when I was researching things about the water cycle. Gosh, there's bits of chocolate and nut everywhere. When I get up, I'm going to have all brown patches on my shorts, which is not going to look very attractive, is it? Right, so I found this clip on YouTube, and it's a girl of your age, maybe a year older, and she's doing an experiment in her kitchen, which she's like creating a mini water cycle with things that she has in the kitchen, and she shows you what she's doing and she explains what she's doing. So you need to watch it for it to make good sense. If you've already watched it, you'll know that she pours some very hot water into a bowl. Using very hot water makes the experiment work a little bit better. If you decide to reenact this experiment, to do it yourselves, I've reminded you please to ask permission with your parents and to ask them to help you pour the hot water to do that bit, because If you have very hot water, you don't want to spill it on yourself. Okay, so she pours this very hot water into a bowl. She then puts another empty, smaller bowl in it, okay, but it doesn't overflow and fill inside. So it's almost like she's got this container of warm water with an empty, smaller container in that. She then puts some cling film, I call it, pellicola, like plastic coating. She stretches that across so it's nice and tight over the top. Okay, now you might not have that at home. I haven't got any of that at home because I don't buy it anymore because I'm trying to not use plastic things. You might be able to use something as like a plastic bag that you might have around and then attach it with an elastic band or something like that. You may or may not be able to do this experiment. You may or may not have the things. But the idea is that the warm water inside, okay, the warmth that's trapped inside will warm the air, which is also inside the trapped inside the bowl with the cling film on top. And the warm air will then be able to absorb, for want of a better word, but let evaporate tiny water droplets up towards the top of the bowl. But instead of them being able to just get out and float around in the atmosphere, they'll be trapped by the plastic coating on the top. Okay, it's a bit like the top of the Earth's atmosphere, let's say. Now, when these water droplets, which when they're inside will look like either invisible or be like steam, hit the plastic, she's tried to make the plastic particularly cold by putting some ice cubes on. Okay, so when those water vapor droplets cool down because of the ice on top of the plastic, they will cause condensation. They will condense back into water droplets like drips. So you can imagine there's this plastic coating and these little drips and blobs of water forming on the underside of the plastic. And when those drips get too heavy, they will drop back down, and any of them that land in that empty pot in the middle will collect. So it's meant to represent the water cycle with evaporation, and then when those water vapor droplets get cold again because of the ice, they condense, they cause condensation and will drip back down just like rain, just like precipitation. So she does a really good job of recreating the water cycle inside that bowl. So have a look at it, listen to her explanation, it's probably better than mine. And if you're allowed to, and be careful with the hot water, see if you're able to recreate that at home, and that should be fun. Okay, so I hope you've had a good week, and I hope we have slightly more successful video lessons next week. I shall send your parents information all about that. All the information is going to go on Teams, okay? So on Teams, one of your team blocks is called Whole Class Work 3ENB. On that team, inside files, I will put what I call my little timetable of just what you do every day, okay? Almost like as if it's on a sheet of paper, so it looks like a timetable. In assignments, for this, so the timetable is in the whole class 1. Work for L1 English will be posted in assignments in the L1 English team. Work for maths will be posted in assignments in the maths team. And work for discovery of the world will be posted in assignments. Assignments just another word for homework, really, work to do. In assignments of discovery of the world. Okay, your spellbound is always posted in the whole class because we all do that together regardless of what our L1 is. Okay, and Jill Bloomfield has put some activities in the music team as well for you to have a look at. Okay, please keep trying to send your work back to me. That's gone really well so far. I've had a lot of work back, not everybody's, but I have had a lot, so thank you for that, and I hope you're receiving my feedback. Sometimes my feedback will come via the assignments, which I don't think you can then say anything to. I think that's the end of it. But if I do a correction, which may look a bit of a mess because I have to use this funny tool, which means my handwriting looks atrocious. If I do one of those kinds of corrections, I then send it back to you on chat, okay, which you can also see. That should ping up as something that you can see. I think that's enough from me today. It's enough for me for this week, I would imagine. So have a good weekend, and I shall get back to you all next week. L1 English, I shall see you at 1 o'clock.